A warm regards to everyone who's watching this presentation. Myself, Sagar Paithankar. I will be explaining my experience in this internship, and you will be learning with me what I have learned in this internship. So, let's get right into it. We will start the overview of the internship. First things first, the goal of internship is why you need to do this internship, what you will acquire during the internship. Emertxe programming. And before going any further, I want to clear that we will be talking briefly about practical purposes of the embedded system. That's why I've included the points of project to be needed. Then we have embedded C programming. It's very much important as during the internship we'll be writing around 500 lines of codes. So yeah. Then we will discuss the brief about embedded systems, which is the core topic of this internship. We will talk about the projects and the things we need to require. We are requiring to implement our project. And at last, we will see the demo and conclusion by my side. So, coming to the goal of internship, first goal is skill development in embedded system. So, embedded system is a core topic in our electronic system design. You can say in every core industries of electronics. So, we will be acquiring some skills to start off with our project, then to get a hands-on experience of real-world projects. See, lively, we make Arduino projects in our college. That is very common and very used to. Even if you see in the Arduino website, that is made very clear that the project is for schools and not particularly for the college. So to work on a real-world project is equally important and necessary in this real-life scenario. Then we should be having a practice of coding of microcontroller. Generally, coding is a broad thing to do. So there are so many languages available. And, we don't really know the specific direction we need to go. So that's why. Then making individuals industry ready. I feel by my side that after completion of this internship, you will find a direction for which you need to go forward. Ultimate aim of this internship is to make ourselves industry level ready, as at least fresh on some level. Then first point that you will come across to be noted that what is C programming and why are we using the C programming to code our microcontroller. So this is a difference I understand during the internship that like various CPUs have their assembly language instruction set. We can use ASM programming, that is assembly language programming, to code each one of the CPU uh, if it is a real world great project. But if you are using embedded C, it is far more convenient. If you that is you can use embedded C for all types of CPU, even if the code is same. That is a difference we need to understand. Then there are some concepts I learned during the C programming during the internships. Our first six sessions on our based on the C programming. Some points and some concepts that I acquire, I want to share with you. Like if you write in a variable and declare it auto, the scope of that variable within the function or within the block, or the life expectancy of this variable is until the end of the block, and memory will be allocated to stack. Like this, register, static, local, static, global, and external. About the external keyword, we will discuss later. This is a great concept. And static keyword is basically you are assigning it directly to the data segment, so you can access that variable over any line of code. It doesn't matter the directory of your file, that is .c file. You can access it among all .c file that doesn't need specified uh, in that particular .c files only. Then about the extern keyword, like for example, I'm extending num variable in this two file from this single file. So this changes I made in the file C will also be made in file 2 and file 1 uh, with the num. When you are writing code for a project, you can't be writing all the code in single files only. You have to divide it in different files and you have to assign these files as some specific task. For that, extern keyword is very much useful. Then the concept of macros, like for example, I given here. This example is also taught in our class. Like if you want to use a specific line of code, then you can just assign it to any particular, let's say it segment, like set bit num pause here. It is doing OR operation of num and a variable we are assigning here. So you can use set bit all over the code, and which will do the same task as this line of code does here. Now coming to our core topic, the definition is pretty much known to everyone. Still, it is a classic one. That is any combination of hardware and software which is intended to do a specific task. Then we call it embedded system. We can understand this further by understand the components of embedded system. The combination of software and the hardware to assign to do a specific task. Like for example, if we take a example of fitness band, it has software and hardware, and it is designed to do a specific task. For say, let's measuring the BPM or SpO2 of any individual. The management systems contains sensors, LDC, and such unit. We should have microcontroller, which is the nucleus of any embedded system. Sensors are the machineries which aggregate analog information, and this analog information is converted digital information by ADC unit. And actuators are actually the hands of an embedded system. If an embedded system, that is a microcontroller assigned to do a task which should be shown in any physical action, then actuators are responsible for that. And such like interfaces, diagnostic, FSA is serial communication interfaces, and memory block, which is available to any microcontroller, not to the processor. Then we are going further to classification of embedded system. There are four types of embedded system we come across: real-time, standalone, networks, and mobile. Real-time embedded system is a smartwatch. We can say further. A smartwatch is a real-time embedded system as it will give us the information at that time only. That's live. And standalone embedded system can be traffic light. It doesn't need any network or any software to run. It will do its task as assigned in this code. Network embedded systems are the embedded systems which are connected to the internet or any type of network, let's say Wi-Fi, Bluetooth, anything. Then mobile embedded system, as the name suggests, our smartphones are the mobile embedded system which we can carry all over around. Then coming embedded system can also be divided into further classification on based on real time, hard, real time, firm, and soft real time. The line itself is pretty self-explanatory. That is, hard real time should meet some deadline. Firm real time, it can tolerate some missing deadlines, but it will degrade the performance of the system. Soft real time is it accepts the tolerance of deadline without degrading in performance, but it is made that way. Now, before designing any embedded system, we should understand design metrics of embedded system. We cannot start right away use giving our hands to the sensors and all. We should understand the time of prototype we need to make, the time we need to invest to make any prototype of any embedded system. The power and performance needs to be decided. The size of embedded system, non-recurring cost. To explain it, the non-recurring cost is if you are buying something in your embedded system, it doesn't cost after all. Like any sensors of an embedded system can only be buy once. You don't need to buy twice or thrice to add on to the project. Like resistors capacitor you can buy during the project. But sensors and all this includes in non-recurring cost. Then safety embedded system should be back in our mind. How much a unit of your project cost and time to market the embedded system to make successful projects. Now, in this specific internship, we will be making a micro home project based on all the information we are going through. See, theory part is important, but I feel what this internship specifically offers is giving you lots of time to building the project, like hard coding the code of micro oven. Micro oven is a real life example which we use in our daily life. and we can implement our skills in this project. What we require for the project? Microcontroller PIC. We will come to it why we use the PIC only. Then fan to indicate that our micro oven is ready, and buzzer to indicate if the time is up. Matches keep at enter the values and a display to show what is going on. Then there is the PIC microcontroller. PIC microcontroller has general input output pins, then serial communication pins, 12C keypad, temperature sensor, ADC unit, LEDs, and so on. So uh, why PIC family we choose? Because it is widely supported by MPLAB ID. What is MPLAB ID? It is software we are using to code in our program. PIC is very cost effective. It consumes less power and it has rich peripherals. Unit of PIC costs less. It has 14 bytes of program memory and 68 bytes of RAM. It has a wide operating voltage. For example, it can operate on 3.3 volt as well as 5.5 volt. And the softwares we'll be using in this project are MPLAB and PiximLab. MPLAB ID and PiximLab. MPLAB XID is a compiler we need to use to maintain our code. You can't compare MPLAB with any notepad because it doesn't have that feature particular to the coding of any embedded system. MPLAB has a wide variety of PiximLab also. Then a big reason to use this software is it is open source. We don't need to pay for it, and it has a wide community built over the internet. Now coming to project implementation, we will be using PiximLab to implement our project, and PiximLab is basically a simulation tool in where you can simulate your uh, PLC board without actually seeing in hardware. Now coming to a demo project, we will open the PiximLab again. So this is a project of micro oven in the PIC. As you can see, PIC 16F8778 is the specific microcontroller board we are using. It has a rich peripheral set and LCD display is 16:4, operating at 12 20 MHz frequency. It can operate on different frequencies as well. Then there are peripherals such as fan, serial communication, relays, and all. So our project is basically a micro oven which we use in our daily life. There are four modes in our project. There is a one screen animation which we can see right here. We will get to the coding part of the project on later of this presentation. First, we will see what this four modes do. So while entering the micro mode, we have to press one. It shows how much power our micro oven consumes. Then we can set the time for it. For example, let's say I want to set is 20 seconds. And we can go any further, but due to time constraint, the presentation has to be compact. You can clear it by the using the keyboard screen. For example, I will show so any time can be entered here. It's easy and convenient. So for now, let's take it to 20 and enter. So this is showing. Um, we can also pause our time. This is what time as per your convenience, and we can stop it also. So that will bring us back to our menu. Just for example, how this work afterwards will be. See, our meal is ready and we are ready to enjoy. Second is a grill mode. Grill mode is same to the micro mode. It has the same interface, user interface. We can also set time here and so on. So coming to our next mode, which is a convention mode. Convention mode is a feature, you can say, in our micro oven, which we have coded. We can actually preheat our meal before setting the time is required to it. That is, if we want our oven to be preheated at 127, 120 degrees Celsius. Very heated. So that the temperature will maintain before we start any timer in our meal. So we'll put some time here. You will find it actually interesting to code all such functions, and when you are coding for a specific task to be assigned, you get errors and situations that doesn't really need to be come off, but it's necessary to come off to overcome that situation. It helps build our logic in that code. On time now. So now at this point, our temperature inside the oven is 120 degrees Celsius. Now we can set the time. Let's say 5 seconds. And as you can see, we can boil it and stop it. Push for convenience. It comes in. So next one is start mode. Start mode is, as the name suggests, it is a mode which you can start right off. You don't need to enter any time here. It's predefined mode which for say, if you have made the food already or it is something you want to eat later on, you can just heat it for 30 seconds. You can also increase the timer, like tapping 4 will increase the timer 30 seconds and pause it as per convenience. So we'll stop it for now as we'll count with a 1 minute second for this. It is a write-off mode and it is very convenient to write also because there are less peripherals required in it and doesn't need much hardware. So as we can see, our food is heated now. We can enjoy it. Coming to the coding part of it, I will not explain and go in detail and all. We will just see throughout how I make this interface and how the backend is working in this. So we are in our MPLabX ID. Now coming to our modes, we have four modes that we have coded. Micro below information start. We will start off by one. It has two main files that is main.c, which will allow us to call the functions which are required for each mode. Like power on screen, we are calling the power on function, which we will write in microben.c file. Basically helps us to organize the code in a lethal way. In layman terms, if we are to experience any error in any future, it will be easy to find. Then first mode is our uh, micro mode. Micro mode starts off right. It's using a function set time, which takes two variable key and reset flag. Not going too deep with the functionality, but basically we are taking key from the matrix keypad functions, which we will take as an input. Like if I'm entering here one, so we are going to micro mode. So this input one is what we are taking as key, and then reset flag. The reset flag has to be reset nothing once we are entered into the micro mode or any mode. So on. These are the message we are printing. And a thing to note here is Uh, you can't print integer as it directly into the LCD display. We have to convert into ASCII value for which the CLC.fetch function is used. This function contains nothing but convert the print what we have taken as a key into the LCD screen. And same function can be noted in grill mode also. As you can see, in grill mode we have used the same function set time, which does nothing but same thing as the micro mode. Here also we are taking key as a parameter and digital flag has to be nothing. We are initializing all the variables we have required for the particular mode. Then going further on the explanation, uh, these are some conditions we have applied to the key in order to make sure our input is clear to the processor. Pressing star will initialize the printer at 0 and count as 2. This key count is actually, you see, blinking here. So this key counts to 0 and 1, 2, it is 3 and is 4. So when you press clear button, you are actually clearing the key count 0, 1 and 2. And if I enter 1, 2, 3, let's say 2. If I press clear now, it is clearing the minute which we have coded in our blink pause program. So likewise, some functions of next mode, that is convection mode. Convection mode we have using set temp function, which used to set the temperature. It is also taking the key and character reset flag as a parameter. We are initializing this key count as 0 in here also. And once we enter in the convection mode, we see the blinking here. This blinking is due to the what we write here, line number 154 to 158. This code has caused the blinking, which we will also observe in the requirement document in our microcontroller project. And it is in here also we have to convert the integer value into ASCII value in order to print that. And the same function if else statement is used, nothing different. But the logic is always being the same. Then the last mode is the start mode. Start mode is very easy to code, as you can see here in Win.c. Last one is start mode. In start mode, we don't have to take any input also. We just start the fan, turn on the timer, and initialize the operational packet display time, which will start the counter as from 30. Now this is already happening due to timer.h, which we have discussed in our internship. As you can see here, timer.h. It has some libraries, and we also have a source file of timers, ISR. In here, we have declaring the mean 10 second is 60. So it is actually decreasing the timer from 30 to 0. And yeah, now moving forward to the conclusion of our project. So throughout the internship, I have a very enriching experience both professionally and personally. As on the personal level, we got to code a little and the doubt clearing sessions and all discussion forums. I really enjoyed it a lot. Asked a lot of doubts to the mentor, and professionally also the internship helps a lot in building the straight career. Second one is we are always ready to start coding straight up, as after the micro project, any project you took up, you would have ideas in mind and how to code for the specific function or so and so. You're also able to understand design metrics of any project before touching the sensors. You should know what the sensors are required and what are uh, professional way to build a project to make it cost effective and economically successful, so and so. We also improved the logical aspect of problem solving. As the ways change, you look up into the coding. If you are coding a software part and suddenly you change your mind to code in a microcontroller part, the logic level is going to be different. And that's what being taught in throughout the internship. So yeah, that's all from my end. Thank you.